just kind of bonkers the way the authors did this. The authors have this as their answer, which means in terms of this area in this region, they were using these horizontal representative rectangles, dy's, whose areas were dy times the x value, so they had to solve this for x. So the area of the rectangle is the length times the width, that times dy. And then from 1 to 10, the y values, limits of integration, which gives us the whole area. So they said, let's find the k value so that if we only start from 0 to this y value, we will have half of the area of the original because it'll take 2 of those to get this. But that's kind of weird because the problem phrased this as the line x equals k, which is necessarily a vertical line, not this horizontal line. They'll get the same k value, but here's the way we should have done this problem. There's the line x equals k. There's region 1 and region 2. They need to be equal to each other. So we let the area from 0 to k, x values for our dx radicand, and that should be equal to the area of region 2, which is from x equals k to x equals whatever this value is. So we can find that x value by setting our y values equal to 10. We know this red line is y equals 10, so this curve, set it equal to 10, and we find out that this is our x value where they meet. So we're going from x equals k to x equals a, where that value is stored in a. All right, I think that's it. When you go ahead and oh, they only asked us to set it up. So there's the setup. We're done with this problem. Of course, I went ahead and solved it. That's the k value, but I could have stopped right there.